welcome back my dear friends. A very good morning, good afternoon, good evening to all of you. And this is the DADM 3 course, which is Data Analysis and Decision Making 3, and you know this course duration is for 12 weeks, which is 60 lectures, and each week we have 5 lectures for duration, each being for half an hour. So, the total duration, if you consider 60 lectures, basically the total number of hours, contact hours is 30. And after each 30 hours, and after each week after 5 lectures we have an assignment. So, there will be 12 assignments, and after the end of the course there would be a question answer or a final examination. So, if you remember, we were discussing about utility, and I did mention in some conceptual framework that why utility was important. So, we will continue that and try to wrap up as soon as possible of the utility function and then go into the optimization. Now, if I consider the utility which I mentioned the generally I considered the quadratic utility function, the polynomial utility function, the linear utility function. So, in the above problem, when there was a government bond, treasury bills along with the option where decisions were 3 options with probabilities of 0.2, 0.4, 0.4, and the values, not the utilities, the values were given in lakhs. So, the question would be, what would be the above problem be? Would it give a different answer if we use a utility function which is uw is equal to w to the power half plus 2. So, half was basically the utility function. Now, you are basically adding a constant here. So, if you basically add a constant here, and so all the utilities function would be just increased by that values, and when you multiply the corresponding probabilities, those probabilities also would basically give you the values as 1, but the some of the probabilities are 1. So, that C value would be just an addition for all the utilities. So, the ranking would not change, provided C is positive. So, if it is negative, there would be cases that if you have to basically compare whether negative values are true or 0 is true. So, obviously, if all are 0, then they become at the same level. If negative values are to be considered, then obviously the ranking would be maintained. So, consider in a span of 8 days, prices of a security fluctuates and a person makes his or her transactions accordingly. So, we consider the utility function to be logarithmic. So, for day 1, 2, 3, 4, 5, 6, the prices are 1000, 97, then 975, 950, 1050, 1050, 925 and 1025. Now, obviously, when these values are given, we are considering them as W, some wealth. They may have different implications also. So, the moment you have those W's and which is the price, you have the utility function which is given as logarithmic. We convert them and find out the utilities. Utilities are given as 6.91, 6.88, 6.86, 6.96, 6.83, 6.93. So, that gives the utility which is UW. So, W which is P is given, then you find out the UW based on the logarithmic one. Now, when I come to the outcomes, so obviously outcomes technically means, consider this scenario, this price of 1000 has occurred 35 number of times in a total span of 100 days. So, if this is the case, we will consider that outcomes giving us some information of the probability of occurrences, which is NW divided by the summation of NW. NW is the total number of sums of the total total occurrences in different numbers. So, the outcomes are given by 35 individually, 35, 20, 10, 15, 5, 15, and if I divide by the corresponding total number which is 100, the corresponding probabilities are 0.35, 0.2, 0.1, 0.15, 0.05 and 0.1. So, if I find out the expected value, again I use the same formula, it is summation of UW into NW, NW is the numbers, summation of NW. So, these probabilities are So, this is given. If I want to find out the utility, I have already mentioned that, but still I will mark. So, these utilities, I am sorry, are given. So, this is the utility, I will basically map them. And if I want to find out W, W's values are here. So, this is the W. Oh, shouldn't be green. I will use a different color. Wait. So, this is the value of W. So, this is the value of W. So, the green basically gives you the probability. This not light orange, a saffron sort of color would give you the utility, and the blue one gives you the W value. So, the value comes out to be 33.63, which is the expected utility for the decision. So, there are some properties of utility function, because I want to maximize, and if you remember in the optimization problem, I also always have been mentioning that trying to find out the optimum one, whether you want to maximize or minimize. The first restriction placed on utility function is that it is consistent with more being preferred to less, that is the property of non-cessation. That means, more I give you, more you want. So, I give you 10 rupees, 20 rupees, 30 rupees, 40 rupees. So, these are on the wealth front. So, when I convert into a utility, your utility function keeps increasing. Now, the question may be asked from your point of view, whether this increase is always happening on increased trend. So, I would say no, because we will try to basically differentiate into 3 categories. I will come to that in a very simple way. So, the first restriction placed on the utility function is that it is consistent with more being preferred to less, that is the property of non-cessation. This means that difference between the two certain investments we will always take the one with the largest outcome. That means, the utility based on the fact it is from the output, which is W plus 1, would be greater than the utility which we are getting from W. That means, the first derivative of the utility function would always be greater than 0, come what may. So, that is theoretically, practically it may not be true. Now, coming to the second property. So, utility analysis important properties would say that if we consider the investment or the decision maker perception of the concept of risk, then we have the concept of the property of risk can be summarized as property of risk aversion, property of risk neutrality, and property of risk seeking. That means, if I want to avoid risk, that means, which means what? I would be getting a main worth, which is always increasing, but my liking for that will start decreasing. That means, it is increasing at a decreasing rate. When I consider the concept of neutrality, I will show you that with the graphs when I am showing the concept of risk neutrality. So, risk neutrality would basically mean that as my value increases, the utility increases obviously as per the first property, but is increasing at a steady rate, fixed rate. And if it is risk seeking, again the property of the first one, that means, more I get, more I want, that is the first the derivative is positive, and this second derivative is also positive. That means, of the utility function with respect to W will also be positive, because it will mean that I want more and more at an increasing rate. So, let us consider a simple example. So, consider I want to play a game with you. So, in one sense we have a coin, which is the unbiased coin, probability is half and half or a head and a tail, and on the other hand you have a biased coin. Consider is the coin, you must, somebody of you must have seen the movie Sholay. So, this is the coin which was used by in Sholay, which is both are the same face, considering the probability is 1. Now, in the first case, when it is an unbiased actual coin, probability half and half, we will consider that if you invest some value, your outcomes would basically be the value will be getting will be 2 with a probability of half, and in another case when it is tail. So, first case it is head, it is with probability half, the outcome is 2. For the second case probability is half, the outcome is 0. Now, if I tell you to find out the expected value, you will immediately find out and tell me it is 2 into half plus 0 into half, which is 1, which is good. The expected value is 1. Now, if I tell you about that bias coin where the probability is 1, you will again say, and the outcome is 1, you will say that for the probability 1, as it is 1, so also the expected value is 1. Now, if I place these two scenarios in front of you, and these two values 2 or 1, which is our notional values, consider they are the outcomes which are coming in rupees, some value you can fathom. So, if I ask all of you which decision which you will take, so and I am sure everybody will say that we will try to take the probability one where the probabilities are half and half. So, that means you want to take that value because you want to take a risk and you want to win a value of 2 and not 0, but the probabilities are same, remember, half and half. Now, let me increase that to say for example 2000, or let me increase the value to. So, when I am using the increasing the value to 2 to 2000, 1 also increases by 1000. So, 1 to 1000. So, in this third scenario, consider that 2 it becomes now 2 lakhs, 1 becomes 1 lakh. But in all the cases which example I am giving, the expected value for both the scenarios would be the same. So, in the long run it would never mean that one is better than the other, but if I keep asking you the question, in this first case when it was 2 and 1, you were tempted to take the decision of the gamble, but as the stakes increases, the value increases, people may slowly change their decision from the risky one, they may become neutral, and in some of the cases they may basically take the case which is the deterministic one, which means depending on the scenarios people will change their decisions accordingly. So, here let me continue. Price for investing is 1 and it is a fair gamble, in the sense its value is exactly equal to the decision of not investing, whatever it is that. So, the values which you are giving. So, not investing means that you just play the game and get the same output, but the values, expected values are same for both of the case, but it will change. Now, if I am considering the concept of so the human being, in the case when you are going to take the gamble, when you are indifferent between the gamble and the sure event, and when you are going to take the sure event, obviously your characteristics are changing. So, those characteristics would be when you take the gamble, you are risk seeker, when you basically are indifferent, you are a risk neutral person, and when you take the deterministic one, you are basically a risk averse person. So, the risk averse person, I will use the highlighter now. So, for a risk averse person, that means I want to avoid, that means the less than equal to sign would hold true with respect to the deterministic one, that means I will be more pulled towards the deterministic scenario. If I am a risk neutral person, obviously I am indifferent. So, obviously in that case it is an equality sign with base to the gamble and the certainty event. And when I am basically a risk seeker, that means I want to run after risk. So, it will be greater than sign, in the sense that I will take that gamble such that the returns to me are expected value. Again I am not going to consider, I am not saying they remain the same in all the cases. I would basically take the gamble because I think in the long run it will give me more benefits. Another characteristics by which to classify risk averse, risk neutral and risk seeking person is by considering the second derivative. If you remember, I did mention the second derivative. The first derivative is always greater than 0. The second derivative will be u double prime by u of or u double prime, which is d2u dw2, u being basically being the utility function, and from there you can find out whether the person is risk averse, risk neutral or risk seeking person. So, in the case if the second derivative is which is less than 0, the person is risk averse. So, that means because the second, which means that they are increasing, but increasing at a decreasing rate, hence I am risk averse. So, if I consider the equality sign, that means I am indifferent. So, it is increasing, but increasing at a steady rate, straight line. And if I consider the greater than sign, that means the second derivative is greater than 0, that means I am considering a risk seeking person, that means I want to take the risk. So, utility analysis, if I consider from the diagrammatic point of view, let me take the pen and in the red. So, in the case if it is so this the first derivative for the green one is always increasing, but if I consider the slope is basically going down, that means it is positive because this is less than is between 0 and 90, it is positive, but the slope is slowly now trying to decrease such that it is second derivative is decreasing. So, the graph, so this basically decreases. So, it is the second derivative decreasing. For the blue line, so technically it would mean that if I am on the green line, I am trying to avoid the risk, that means I am a risk avoider. For the blue line again, the first derivative is increasing and the second derivative is also fixed, because if the first derivative is increasing, but is fixed, that means the second derivative basically becomes 0. That means we cannot say whether the person wants to take the risk or avoid the risk. So, he or she is a risk neutral person. Now, if I consider the red line, so the red line is going like this. So, the first derivative, so in between 0 and 90 degrees, the first derivative is obviously 0, but the tan of that angle, second derivative of that angle basically starts increasing, that means which means that I am willing to take the risk, which means I am a risk seeker. Now, I have considered the marginal utility. Marginal utility means the first derivative concept. So, marginal utility functions looks like a convex function, which means I am a risk averse person. Marginal utility function looks neither like a convex nor a concave function, which is a risk neutral person. And marginal utility function looks like a convex function, risk seeker. So, that means if it is a convex function, that I am a risk seeker means I want to love risk. So, it will be increasing at an increasing rate, and for the first case it is increasing at a decreasing rate, and for the second case it is increasing at a constant rate. So, if I consider increasing, that is what I said, marginal utility rate is increasing at a decreasing rate, which is risk averse. Marginal utility rate is increasing at a constant rate, risk neutral. Marginal utility rate is increasing at an increasing rate, which is risk seeking. So, these are the graphs. The green one, so it is sliding going down. So, the tan of this angle is decreasing, second derivative is basically decreasing, it means d2y, d2u, dw2 is now negative. So, it is a risk avoider. Considers the blue line. So, dy dx is positive, d2y dx2 is 0. So, in that case it is basically a risk indifferent person, whatever happens he will take both the decisions with equal values, because he is trying to basically, he or she trying to value the expected value and find it out. In case is a risk seeker, so the line is increasing. So, in that case the first derivative is obviously positive, second derivative would be as the tan of that angle is increasing. So, obviously the second derivative, which is d2u dw2 is positive, and that person is a risk seeker person. Now, consider the marginal rates. So, if now and their implications. So, if I am a risk averse person, which means I will reject a fair gamble, and the second derivative, as I have been telling about the green line, would be the second derivative would be less than 0. If I am risk neutral person, I will be indifferent to the fair gamble, which means that my second derivative will be 0. If I am a risk seeking, you will select a fair gamble such that the second derivative would be greater than 0. So, now we will basically consider, now this would be become important when we consider a few simple problems from the point of view of optimization for finance. So, absolute risk aversion property or for that utility function would basically mean where this absolute risk aversion would be given by the value of A, which A is an absolute risk aversion property, and that will be given by minus u double prime by u prime. So, now consider u prime is always positive, which is the denominator. In the numerator you have u double prime. So, u double prime will be positive, negative or equal to 0 depending on whether you are risk seeking person, risk indifferent person, risk avoiding person. Such that combined with u double prime's property and the minus negative sign, you will basically have the property given onto A, which is absolute risk aversion property, and A prime. Now, I would not go into the details. So, generally you can prove the concept of absolute risk aversion property and generally relative risk aversion property will come to later by using a simple fair gamble with a value such that you are risk neutral and then expanding it using the Taylor series expansion and solving the problem. So, they are more from the theoretical point of view, but we would not consider it as it is, but I will just read it out. Assuming an investor has wealth amount W and a security with an outcome represented by Z, which is a random variable. So, the outcome will change. So, assume Z is a fair gamble. Fair mean gamble, that means the gamble based on the expected value for the gamble and the expected value of the sure event would be same. Now, we are considering the expected value of the gamble is such that it is equal to 0. So, obviously, they have fluctuations positive and negative, but is 0, and the variance is given by sigma square suffix z, and the utility function is, say for example, u w. Now, if we choose WC, a certain amount of wealth, so what we are trying to basically balance is WC on the right hand side and the fair gamble along with that money is on the left hand side. We want to basically balance them based on the fact that as the random fluctuations are there, in the overall run the average value basically comes out to be the same. Now, considering this absolute risk aversion property, now if the person is indifferent between decision and choices A and choices B, so you will basically balance both the left hand side and the right hand side, which would be given by this equation. Which means the person is willing to give maximum some amount, which will be basically the difference between the WC on the right hand side and the value which you have along for the case when Z is there. So, in the first scenario on the left hand side you have W and Z, which is fair gamble, on the right hand side you have WC only. So, the differences would basically give the balancing act. So, if I basically expand u w plus z using a Taylor series expansion, you can find out the absolute risk aversion property. Now, if I consider the absolute risk aversion properties in general, so if I find out the derivative of A, which is dA dw. So, in the three scenarios when you have a risk avoiding person, risk seeking person and risk neutral person, the answers would be answers means the concept was coming out to be A prime is less than 0 means decreasing absolute risk aversion property. That means my aversion for risk in the absolute sense will start decreasing. If I am basically A prime is 0, that means I am a constant absolute risk aversion property, and if A prime is greater than 0 is I would have basically have, or the person would have an increasing absolute risk aversion property. So, decreasing absolute risk aversion property, which would mean wealth increases, the amount of held in the risky asset basically increases. Now, it mentions about the quantum, nothing to do with the percentage time weight. So, that percentage would come later on. So, if you have decreasing absolute risk aversion property, so obviously we know that A prime would be less than 0, but it will also mean conceptually as wealth increases, the amount held in risky asset also increases. Similarly, when I go to the second one, which is constant absolute risk aversion property, where A prime is 0, it would mean that as wealth increases, the amount held in risky asset remains the same. And in the third scenario, if it is increasing absolute risk aversion property, which is A prime is greater than 0, which means that as wealth increases, the amount held in risky asset also increases. So, you basically find out using the properties of A and A prime, and provided that would obviously come from the property of U double prime. Now, consider the relative risk aversion property. So, we have considered the absolute risk aversion property, we will consider the relative risk aversion property. Now, in that case, the value of A which you have, you will just multiply it by W. Now, let us come to the details. So, it is now minus W into U double prime by U prime. So, U prime we already know it is positive, has to be positive. Now, U double prime would be greater than 0, equal to 0, less than 0, depending on the property of risk aversion. So, if I like the risk, do not like the risk, I am indifferent to risk. So, and my overall decision will be based on the fact that what is the value of A and A prime, and that would basically have an effect on the what is the value of R and R prime. So, consider the same example. Okay, now we want to basically prove this concept of absolute risk aversion property. Now, we will basically go in the relative risk aversion property, we will go into the relative sense. So, the main difference between the absolute risk and the conceptually how we analyze it. In absolute risk, we will try to find out in the absolute sense the increase and decrease, while in the relative sense it will be the proportions of the probabilities. So, we will basically find out the probability based on the amount of investment which have been done, which is W. So, here also the expected value, there the expected value was basically 0, we will consider in the gamble the expected value is 1, and therefore, for different values of W invested, we obtain the values of W into Z and do again the simple concept of Taylor series expansion and find it. Now, relative risk aversion property. So, for the investor to be indifferent between the two decisions, we must have the utility which I am trying to find out using W and Z, and remember we are trying to find out in the relative sense, and the utility we are trying to find out for the WC, which is my actual investment. So, actual investment is there on the left hand side, there is certainty and a uncertainty factor. So, again use the Taylor series expansion, you can get the values. Now, you may be think, okay, let me come to one important point. So, here the decreasing relative risk aversion property again we will consider R prime P less than 0, it is decreasing it will be decreasing relatively. So, that is why it is in a relative risk aversion property. Constant would basically be the constant constant relative risk aversion property, and increasing would basically mean when it is greater than 0, that means R prime. So, this is R prime, this is R prime, this is R prime. So, that is greater than less than 0, equal to 0 and greater than 0. So, that will also give me the concept of relative sense. Also, you have in the absolute sense, and we will try to combine them to find out the properties of the utility functions and try to utilize them later. With this, I will end this 5th lecture. Have a nice day and thank you very much.